Hi everyone, let's do the level hell of this tutorial in which I'm going to show you how to make a web app. What I asked you to do if you already did all of the above tasks to make an interactive plot. So my idea was to make a Gaussian distribution, and then in the web app you should be able to change the mean and the standard deviation. What I suggest you to do is either use Bokeh or Streamlit or some of other ways of doing that, like the web app or the libraries available for Python that are indicated in the lecture notes. What I'm going to do here is I'm going to show you how easy it is to use the Streamlit to make such a web app. Sorry. Now, there are a few things that you need to do in order to make a web app on Streamlit, and I'm going to say what these things are. So let's turn this into a markdown. So the first thing, you need a Python code. You're going to need a txt file with the requirements. I'll explain what that is. You will need an account on Streamlit, and you're going to need an account on GitHub. I mentioned GitHub already. So let's first do these two things. So the account on Streamlit, I already have one, but you can sign up for that. And then an account on GitHub, I also already have that, but I can show you how it looks like. So the Streamlit account, I'm going to show you. I open a new tab and I Streamlit. Here I can just sign in because I already have an account. It just loads a little bit, give it time. And there you go. So here you can, I already have my account, I have something running there, and then I can make a web app. I'll show you how. So the GitHub, I also already have accounts. So you need to make a repository. As I indicated, so let's make a new repository here. Actually, let me just show you. So when you go to Streamlit, to GitHub, then you can see your account data and all sorts of things. And we need to make a new repository, and this repository needs to be public in order for Streamlit to read from it. So let's just do a new repository. I'm going to call it Computing Course 2022, and this is going to be a public. Add a README file and create a repository. And I hope I already have something saved for the README file. Yes, I copy that. So this is I just say what this repository contains. That contains a collection of data and code used for this course, Scientific Computation with Python, and we just make commit changes. So I just say what I changed. I said updated the README and commit. And there you go. So when you go to the computing course, and then you will see that there is just a README file that contains this part, and now I can upload stuff there. So we did this, and so I have two things out of what I said. I need an account on GitHub, I need an account on Streamlit, which I already have. Now we need to write code. So what I said, let's go back. The interactive plot, basically just make some sort of Gaussian, but then you choose your mean and your standard deviation to play around with it. So let's just make, in the tutorial part, I'm going to make a Python file. I'm using PyCharm, you're using Spider, so whatever you prefer your IDE to use to make to write code in Python, not Jupyter Notebook. So Python file, I'm going to call it. This needs to be called in a certain way, so that's one of the requirements. So Python file needs to be named Streamlit app. That's how it needs to be called, Streamlit app. And then let's just start by importing some of the libraries. I know that basically because we already played around with Gaussian, so we know that I'm going to need a NumPy, SciPy, and I'm going to need pyplot, a matplotlib pyplot. So there's three things I need to import. So import NumPy as np. So import SciPy, and already suggests, right, this spider does for you as well. Import matplotlib pyplot as, come on, as plt. And I'm going to need the fourth thing, because we want this Python file to work with Streamlit, we need to import Streamlit. So you need to actually install it on your machine, I think. So do that, you just do pip install, or in if you go to Streamlit, you can just say download or how to install, and then just follow the instructions. Should be very straightforward, especially if you have a Mac machine. And then I'm going to say import Streamlit as sp. st, sorry. That's not a Streamlit, as st. Those are the things, so I'm just going to say this. Okay, so import Streamlit, import NumPy, SciPy, and that is it. I'm also going to, maybe just for the sake of the code, I'm going to say import, no, from SciPy stats, because we need the norm PDF. So from scipy.stats, import norm, because we're going to use that to create a Gaussian. So what we need to do is basically arrange, let's just do the Python code first, right? So we need to create a Gaussian within some range of x values. So I'm going to say that my x is going to be some NumPy arrange from start, stop, and step. We can hard code 0.01, let's say. So I'm going to leave the start and stop, because we can also include that in the app. So not only to change the mean and the standard deviation of a function, but you can also say where the data should start and where to stop. So that could be a variable. And then my y is going to be norm the PDF, and then I'm going to have x, norm PDF, yes, x, and then I need my mu and sigma. So mu is the mean, sigma is the standard deviation. So we need to have these four things set as variables. So I'm going to have something like start is equal to something, stop is equal to something, mu is equal to something, and sigma is equal to something, right? And these things we want to have on the app for the user to be able to tweak them. And then once we have this, for now, I'm just going to say, let's just start at -50. Let's stop at +50. Mu can be equal to 0, and standard deviation, let's just say 10 for now. Now I hard coded it. As I said, we're going to put it on the web app in a different way. And let's just see if this is going to work. This should work something like we want to have a plot. Fig arcs is equal to plt subplots, and then just say fig size. Sure, let's choose something like 10.5, maybe should be okay. So it's not too big, not too small. And then x is dot plot, and then we can just plot x and y. I can choose the color is equal to, let's just do the black color, and line width equal to something like that. And I want to indicate the mean on it. We already did that in one of the previous tasks. So ax v lines, and then I will have the position in the x coordinate is going to be as the mu, and my y min, well, is going to be equal to 0, and then y max is going to be equal to numpy max of my y. Color is equal to, let's just do black again. Line width is equal to 2. Line style, something like, let's just do dashes, so 2 minuses, and we can also label, if we want to put mean, that this is the mean of the function. And we can also, as we did before, we can fill in the standard deviation, something like x fill is equal to numpy arrange. It needs to go from mu minus sigma. The second, the stop needs to stop at mu plus sigma, and it can be something like 0.01. And then y fill is going to be a norm.pdf, right? We need to make a PDF, but to cut it out in the x, it needs to go from x fill, right? It needs to go there, and then you are going to generate it with your mean and your sigma, and then you fill between the lines. So you're going to say plt dot fill between. You're going to fill between x fill, y fill, 0. Let's do the transparency of 0.5, and the color orange. Color is equal to orange. I think this should work, and then we can say plot the legend as well, and then plt show if necessary. Okay, so this should work. This part of code should work. I think we can actually test this by copying this code into our notebook here and just see if this runs. Something is wrong. Oh, of course we forgot this is good to check. We forgot the equal sign. Yes, this does not work. I need to do it again. Why does this not work? Let's see. Okay, this works, and then I have forgotten something and I do not know why. So this works. Oh, of course, because max of y, I think. Let's see. Yeah, exactly. Okay, I made a mistake. I made a different. Very good, very good. So we should have something like this on the app. Okay, we debugged it. I had a max of x, not of y. You see, if you do it like this, I had it before like this, it doesn't work, of course. Small mistake. Okay, so this thing works. So let's just copy it back to the Python code because we had this problem. In there, I'm just going to replace this. Okay, so this thing works. Now I now want to integrate this with Streamlit, and you'll see now this video might be already 15 minutes, but if you know how to do it without, talking through it, it's actually you can make this app in like under 5 minutes, I would say. So we want to make sure that these are the buttons. I had an idea, let's just do these buttons. So basically, if you have an app, like if this is a blank screen, then you can have some sort of default. These values that I already hard code can be default values, and then the user can, for example, input a number of start and stop. So this is where your function is right defined from -50 to 50. and then use a slider to get to tweak the distribution by sliding through the values of mu or sigma, choosing like that. So then you can go Streamlit documentation, something like that. And then you can actually find some cheat sheet. There is a cheat sheet for quickly. So this is how you can install and import and command lines. Or if you're not using that, what you can do is configuration, advanced, get started, create an app. You can go through these. It's very simple things. Components. Where did I find this? Get started, share your app. This is already let's see. I know that this was theming multiple apps. Here we go, API reference. So you can say the widgets. This is what we need, the widgets, and we want the number input, something like that. Yes, they have number input, so this is a function. And you just need a label. You can copy this. So we can do the number input for the start and finish, for the start and stop of our NumPy array, right? So I can just copy this and let's just put it here. So it should work something like, oh, this is maybe not a good way. Let's just see what we need. Do we only need this label, minimum value, maximum value, and value? So I'll just copy it like this. Something like this. So Streamlit number input, and then the first thing is the label. So my label, I'm going to call it start, and I'm going to say start is equal to Streamlit, and then you say start, and then the next thing that we need, minimum value, max value. I think that there will be no minimum, maximum. Okay, we can leave that the default, and then the value. We don't want to have it 0. We can set the value. We can say value is equal. What would it say? We want it minus 50. Minus 50. So this is our start button. This is all you need to do in order for this thing to work, right? And I'm going to comment this out. And then let's do the same thing for stop. So stop is going to be equal to Streamlit dot number input. And then the first thing we need to have the label is going to be called a stop. And then value is equal to, we said 50. So that's it. Let's delete this. Start and stop. We already did that. Start and stop. And then for the mu and sigma, so we don't want the number input of the user, but we want a slider. So let's find it in the reference. Slider also needs a label. Min value, max value, and a default value. Step, we can also play around with that, but we can just do the simple stuff for now. And the point is, like, you can see that the simple stuff works, and then you can extend and, you know, use more arguments to tweak your app. So st slider, let's go there. So we say st slider. So we need a label, if I remember correctly. Yes, label. So it's going to be mean. Let's just call it mu because we called it mu, and I said mu is equal to this, and then we say the value is equal to, what did we say, 0, and then do the same thing for the standard deviation. So sigma is equal to Streamlit dot slider, and then we say sigma, and then set the value, the default value, to be 10. And let's delete these 2 rows because we just defined them already. Okay, and this should be it. So we have the fig is equal to this, blah, blah, blah. I think this should all work now. And then the only thing for your app that's left to do regarding Python file is to see the pyplot. And we need to see that pyplot. It should be somewhere here in the documentation. Streamlit pyplot. Yes, it's called st pyplot. and then you just specify your figure, and that is it. You have the quarks there, of course. It's just for the save fig function in the, but this is your example. So you just say well, basically they already did here a random distribution, and then you just wrap your figure in this function of Streamlit, and it should display it on the web app. So let's do that. So it should be the last part of code. It should be streamlit.pyplot, and then we already have the fig in there, and this is your code, and this should already work perfectly. So let's try now. Another thing that I said that we need to do is to have the requirements, the txt with the requirements. So that refers to the Streamlit in your GitHub. They need to know whatever libraries you imported here. So we use the NumPy, SciPy, SciPy. We used it in this way. We actually, yeah, that's okay. We actually that might be, now when I'm thinking about it, let's just do SciPy as SP, and then we can actually here, where did we use it? We use it only when we were creating this. So it's going to be SciPy dot stats dot norm PDF, right? SciPy stats, yes. Let's delete that. So now we're using all the libraries. So we have 4 things. We have NumPy, SciPy, Matplotlib, and Streamlit. And then we need to just create a txt file with the requirements, what is the version of each library in order for this thing to work. So the way you do it, I would just open my teaching computing course and tutorial. I'll just make a new, how do you do this on text edit? I can cancel, and then I can open new one, and then format, how to make plain text, I think, yes. So what I need to do is I can say matplotlib greater equal to I don't know, 3.5.1. You can check the versions of these libraries, so I know that already. And then also semicolon Python version. You can copy this file from me if you want, or you can just look it up online of 3.7 Python is what we need. And the next line, you can say also matplotlib. We don't need this one. Maybe Streamlit. We have Streamlit. Don't capitalize it, please. Streamlit greater equal than 1.61. No, that's for SciPy. 1.12.0 was for Streamlit, and then SciPy version, SciPy it really just wants to my autocorrect here. This is really annoying, is it? Sorry about this. Greater equal than 1.6.1 with Python version greater equal 3.7, and we also, let's just save this. Save it in teaching. No, let's just save it on desktop or somewhere. Desktop. We need the NumPy version, current NumPy version 123.4. So we can add that NumPy numpy greater than 1/3. What was it? 123/34. 123 and 4. Yeah, we can just maybe copy this with Python. I think this should work. Okay, we save that. We can save, rename, and it has to be called requirements .txt. Okay, let's see if this is in our desktop. Where did I save this? Desktop. Let's see. Yes. Okay, now we need to upload this thing and our Python file to our GitHub repository. So we can add, you can do it through the terminal. If you know how to do it, I'll just show for everyone. You can just go to repository, upload files. So what I need to do is upload these requirements. I just say uploaded recs. And then we need to find our tutorial, our code, Streamlit app Py, so it has to be called like that. Let's I'll add another file, upload the file, and that is the Streamlit app.py, and say uploaded Streamlit code. Commit. And this is where you have your requirements is Streamlit app Py. So hopefully this works. Now you go to your Streamlit account and you start a new app. Newcastle's repository. The public one is Computing Course 2022. This is where a thing is. Yes, it's there. It's the main branch, and the main file to path. This is what they want you to have. This should be okay. So deploy. And you wait, they cook the app, we say the app is in the oven. I think that's super cute. And hopefully this works. Now we'll see. If it doesn't work, it will give you the, it will complain, and you can manage to the changes. Just takes a little bit of time. It should be very quick actually, because this app is not really complicated. We can remove these tabs. Just give it a few more seconds. Should be pretty fast. Hopefully this was nice. I don't think this was really too complicated or too long. It's just taking too long because I have to talk through it, and that's what takes a lot of time. As I said, you can basically code this, put everything online in under 5 minutes for such a small, simple thing like changing the Gaussian distribution by changing the mean and the standard deviation. Okay, something's going on. Do we have an app? We have an app. There is something. Why Phil? Okay, so we know that this is complaining. We have the slider, right? We have the slider, already works, but something doesn't work, and we can see here that I forgot to change this norm PDF because I wanted to work around the requirements and the import, so I can just go back. I would not recommend it. I mean, you can change it directly on GitHub, which I'm going to do. You should maybe do it on your computer, see if it works, and then commit another version of the Streamlit app document, the Python file, but I'm just going to do it here. I can edit it here directly on GitHub, and this was the problem, right? Because I did not import from SciPy stats, import norm, I just use the SciPy. So you can just copy this part here and change this here. And I say change the SciPy stats function name, something like that. It doesn't have to be really. So commit changes. Now it because this is live online, right? And Streamlit is reading the file from my GitHub. They should work auto, and there we go. It is working automatically. There we go. We have an app. We can change the shrinkage, change the sigma, the standard deviation. We can move the mean, so it is at I don't know. Oh, is it our step size? Is too small, so we can change that as well. What was our step size in mu and in sigma? Let's see, how did we do that? Slider should have an argument step, so we can change that directly. Say here value, and we can say, no, not here. Oh, I'm an idiot. Why am I doing it this way? It is here. I can say step equal step equal, let's just do 0.5, and let's do it here. Step is equal 0.5. Let's just make this code nicer like this. That should work. Change step size for mu and sigma. Always make sure to comment your commits. Commit change, and then let's see here, page not found. Let's see now. What is wrong? Step, it should work. Step. Let's see if this has some problems now. Maybe it does, maybe it doesn't. Please wait. Yes, it works. Huh. Something is a bit with our mean. Did we make a mu step is equal 0.5? I see no problem. Let's maybe change its step size again. Maybe it will work better. Just a step size 1. Change step size for mu. Okay, is it running? Yes, it is something running. Line 13 is exactly here. So I'm not sure why. Let's see. Quickly, let's just delete this and put it back the way it was. The value is equal to 0. Changed mu to step default. Something like this quickly. Let's see if it's going to work now. Okay, now we can yes, and now the max is 1, and oh, I see, it goes from 0 to 1 and 0 to 10. I thought that the value, the default value, maybe we did not do this properly. So let's see what is the max value, min value, and this is the value of the slider when it first renders. Did I make a mistake? What was our value is equal to 10 of sigma and mu, so the mean is around 0, and this is what it shows. But then it says that for pyplot we don't need this anymore. Min value, permitted value, defaults to 0 if the value is an integer, 0.0 if it's a float. It defaults to 100. Okay, let's maybe change our code to integers. Maybe then we will not have this. Changed format for mu and sigma, d-type. Okay, start, stop 0 and 10. Let's see now. And now it is complaining line 17, probably at the STD. Yes, exactly. Let's change the step size now, because now it's an integer. Let's just see what's going to now remove the step size for sigma. And now it should probably work. Let's see. Yes, okay, yes, okay, now we learned something. So it is really a problem of, here how your data type, if it's a float, if it's an integer, or then how you can do your step sizes or your values, and what is the default, like what is the min and max value. So you can play around with that, but okay. So now you can make your distribution wider and wider with a slider, right? You can shift your mean around 0. You can move your distribution to the other side, but now you need to have maximum, I don't know, 70, for example. You can just do the number input, right? And that is how you do it. Now this another thing that I could stop the video now, because we're already 37 minutes in, but really it is a lot of back and forth. What you can do is to just instead of having these input, the input of the user on the top, you can have it in the sidebar, and that is actually very easy to do. So, and we also want to title the app, so we can just change the code quickly. We can do the sidebar first, or the title. We can just do Streamlit title, and we can title. Did I read it correctly? Yes. And you just say Gauss app, and let's just push that thing. We can say added app title, commit. Let's see if it's going to show up here. It should show up immediately. Okay, we're missing a parentheses, one of them. Exactly. Okay. Syntax. Yeah, just write that. Now it should work. Come on. There we go. We have a title. It's as easy as that. And we want to move these commands into the sidebar, and that's going to be very easy. We just say Streamlit sidebar, and it is just this is how you do it. You just say with st sidebar, and then you use all the elements. So elements are our button, sliders, and so on. So the way you would do it, you just open your code. As I said, I'm working directly in GitHub. You should not do that, but I'm just doing it for the sake of speed. So what we said, we want these 4 items: start, stop, mu, and sigma. So these sliders and buttons, or the number inputs in the sidebar. So you can indent that, right? We indent it. And then I'm going to say with, the way that they said, with st sidebar, and we can say something like a header. So I know that already, that it's called streamlit.header, and you just put a string there. What we can say, choose your distribution parameters here. This is going to be in the header, and then our start, stop, mu, and sigma is going to be there. and I can say added sidebar to the app. And let's see how it looks now. Now it's going to run. There we go. So you see now your picture, your plot is here, and your parameters are here. Mine is 50, 50, 1. Oh, sigma can't be 0, so you can work around that if people choose it, there is going to break, right? Well, it's not really, yeah, 0, it can't be 0, but it can be 12, for example. Okay, and then I want to add my some information about who made this, so I can also do that. I'll just do it in the sidebar, something like adding markdowns, so you can all check all these things. So this is the things like the widgets that you can do, and then text elements like markdowns and stuff like that. So I'm just going to do it directly here within the sidebar. So I need to say st markdown. My name is Niko Šarčević. st markdown, something like my GitHub .com/Niko Šarčević. I can say markdown, maybe what is the call? This course is called the Mass 280 Physics 2039, if I'm mistaken, at Newcastle University. And I'll add another thing. I'll add the date. It is November 2022. So these are the things that I added here. I'll just set it added info to the sidebar, commit changes, and this should show up somewhere here. There we go. So that is it. I know that this is almost 45 minutes, but if you just follow this once, and then you can create an app, for example, for some other function with to tweak the parameters, tune them, and just play around with it. And I promise you that now, when you know how to do this, you can do this in literally under 5 minutes. Okay, thank you for listening, and I hope you had fun, and good luck. Bye bye.